Hi guys, it's Griff again. I'm sorry I can't be with you tonight. As we said before, the time difference is less than convenient. But anyway, tonight I wanted to present to you this puzzle cube. Apologies for the camera over my shoulder and exposing you to my pasty white knees, but concentrate on the cube. The reason why I chose this is because it just demonstrates how far you can expand an inventive mind. And whereas most inventions are designed to make life simpler, this is deliberately designed to make life much more complicated for no rational reason. And that's why I love it. So let's take a look at it. Really intricate designs on all 6 sides. This is an assembly kit, by the way, 580 pieces. It took me 50 hours to put together because each part has to be meticulously pushed out of a laser cut board and then deburred and polished. The plastic is particularly awkward because it's 3D printed and therefore thermoplastic, which means it doesn't file very easily without micro melting. But it's important to spend the time doing that because the close tolerances are essential. So let's have a look at it. We've got a very complicated steampunk type of design here, which is all lock solid. A nice wheel mechanism here, again, locked up. There's a slider mechanism here of some description that's lock solid. Here's another wheel. And there's a combination lock here, which we'll come back to later. The only thing that will actually move at the moment is these quarter cogs here. Now, look at this. This quarter cog will turn and partially unveil a mechanism here. Unfortunately, this is still locked, so we can't get to that. But it also releases this. When this was closed, the plate here is butting up against the side. But when this is open, the plate is allowed to slide through. Look at that. That's just beautiful. Precision. And in so doing, 2 rods slide apart. This rod appears to relax some form of constraint on the wheel here. And similarly underneath, a very similar effect. We're actually retracting some sort of lock or ratchet on these wheels. Does this wheel turn now? No, seemingly not. And on closer inspection, we see there's a peg here that is stopping it rotating and a secondarily here. So there's a problem with this wheel. What about the top wheel? Now this is turning. So what's happening? It's not only turning, but look at the mechanism inside here, the way the cogs are rotating around each other. It's really lovely. Not immediately obvious what's happening until we notice there's a gap in the wheel here. And that is tending to align with this. In fact, it butts out there. That will then allow this to rise if it wants to. And this is attached to this mechanism. So does this work now? Yes, it does. What's happening here? Well, the most obvious thing that's happening is this pointy finger here is retracting. And it was this pointy finger that stopped this turning. So now this will turn. Beautiful. That unveils this mechanism, which retracts the peg on this wheel. What else is going on here? The fact that we've rotated this quarter cog here is also allowing this to move through it in much the same way as this did earlier. So now this mechanism works, and that's retracting this pin. So now that we've released the lock ratchet here and these 2 pins, this wheel will probably work. Ah, what a thing of beauty. It's just like the old-fashioned camera apertures. And that unveils a finger hole in here with an arrow, which is inviting us to press down, but it's not going anywhere. And that's because if you look very carefully, there's a restraining pin in here, which draws attention to this mechanism. and in turn to the combination lock. Now, 5 knobs, which ordinarily would mean 100,000 combinations, but if we look at the symbols around here, there's only 5 different symbols around each wheel. So that reduces it to 3,125, I think it is. The next thing we notice is there are images on each of the knobs. The little hand here, which kind of corresponds to this here. So realizing that, you soon conclude that each of these knobs refers to a face of the cube. Yes, this is the little hand, indeed. We've got the 2 counterfacing quarter cogs. Where are they? Round here. We've got the sliders here. The iris underneath here. And presumably those are the 3 cogs that feature in the center of this wheel. Having realized that, and noting that there are 5 symbols here, you quickly realize that these are in fact numbers. The line is 1, the V is 2, the triangle 3, the square 4, and the pentagon 5. And then soon after that, you'll realize that you address these in the order in which you originally approached the problem. So the first thing we did, if you remember, was play with this quarter cog here. So we'll put this on 1. That led us to the slider mechanism. Where's that? That was here. So we'll put, where's it gone? I've lost the, there we go. Sorry about that. We'll put this on 2. It's already there, in fact, after all that. Then that led us to the real steampunky bit here, which was 3. No, it didn't, in fact, did it? That led us to the wheels on the top, which is 3. And then that led us to the steampunk, which is 4, which is the square. And then last but not least, the iris, which is 5. So does that? Yes, there you go. It works. Look at that. So now, with any luck, this will work. There you go. Wonderful. Absolute masterpiece of mechanical engineering and steampunk design. Can I put it back together again now? I think this was the last thing we did. Then here, here, here. You can see I've done it a few times already. There we go. So, yeah, a little bit off-piste tonight, a little bit different from normal, but as I say, it's just demonstrating how far you can stretch an inventive mind and come up with something that's never really been invented before, never even thought about before, and how you can make life unnecessarily complicated. Anyway, I hope you enjoyed that. Again, sorry I can't be with you. I'll catch up with the highlights tomorrow, and I'll see you next time. Till then, all the best from the UK. Take care. Bye-bye for now.